A competent rigger can use various types of ropes, slings, chains, and accessories for lifting. A competent rigger can calculate the safe working load of any rope, sling, or chain used for lifting. A competent rigger can assess the weight of loads to be lifted. A competent rigger can select and use the appropriate safe slinging techniques. A competent rigger can safely sling loads of different weights and sizes. A competent rigger can direct a crane operator in the movement of a load. A competent rigger can give hand and whistle signals used for directing loads. The weight of some loads will be printed on the delivery document or marked on the load. Do not lift a load if you cannot make a reasonable estimate of the weight of the load. In considering the potential hazards of a lifting operation, due regard should be given to hazards of the lifting activity itself. The lifting activity will include hazards about the weight and size of the load. The hazards related to the location of the work refer to whether the transfer is at a shore base, at an offshore installation, or a ship-to-ship. The hazards related to the complexity of the work refer to the load center of gravity and availability and location of securing points. The hazards related to the circumstances refer to the environmental conditions like rain and wind. Preparing for the lift includes the technical preparation. This is developing the lifting plan. You should also prepare for the practical aspects of the lift. The technical preparation should include the equipment, the tools, and the information required. The practical preparation should include an assessment of the working method and the expected duration of the lifting operations. Before cargo is transferred, a cargo manifest is reviewed by the receiver and the sender. The first thing to note is the weight of the cargo, because weight is a limiting factor in how much cargo we can carry safely. We also check for the presence of dangerous goods in the cargo, because these will require some segregation or other special arrangements. We also need to consider the size of the cargo, because size is a limiting factor in how much cargo we can carry safely. The volume of a solid block is the length multiplied by width multiplied by height or thickness. The volume of a cylinder can be found by multiplying the radius squared by pi multiplied by the height or length. The formula in the slide uses the diameter. The volume using diameter is 0.25 multiplied by pi multiplied by diameter squared multiplied by the height or length. The table above shows us that a cubic meter of water weighs 1 ton. But a cubic meter of solid wood weighs about 600 kilograms. A cubic meter of steel weighs 7.8 tons, and a cubic meter of concrete weighs 2.4 tons. To calculate the weight of a concrete block, we have to calculate its volume. The volume of a solid block is the length multiplied by width multiplied by height. That will be 3.5 meters multiplied by 2.2 meters multiplied by 1.2 meters. The volume of the concrete block is 9.24 cubic meters. The density of concrete is 2.4 tons per cubic meter. This block is 9.24 cubic meters, so the block weighs 9.24 multiplied by 2.4 is equal to 22.2 tons. To calculate the weight of a drum filled with water, we have to calculate its volume. The volume of a cylinder can be found by multiplying the radius squared by pi multiplied by the height or length. That will be 0.5 squared then multiplied by 3.14 multiplied by 1.8. The volume of the drum is 0.35 cubic meters. The density of concrete is 1 ton per cubic meter. This drum is 0.35 cubic meters, so the drum weighs 0.35 multiplied by 1 is equal to 0.35 tons. Let's talk about taglines. Taglines must be made from a single, continuous length of manila or other suitable non-conducting synthetic rope. Apart from the knot securing the line to the cargo, there should be no other joints or knots in the line. Taglines should be long enough to allow the personnel handling the cargo to work in a safe position well clear of the immediate vicinity of the load. Riggers should keep taglines in front of them and between the user and the load. Taglines should be long enough to allow the personnel handling the cargo to work in a safe position well clear of the immediate vicinity of the load. The reef or square knot can be used for tying two ropes of the same diameter together. It is unsuitable for wet or slippery ropes and should be used with caution since it unties easily when either free end is jerked. Both live and dead ends of the rope must come out of the loops at the same side. The figure of 8 knot is generally tied at the end of a rope to temporarily prevent the strands from unlaying. The figure 8 knot can be tied simply and quickly and will not jam as easily as the overhand knot. It is also larger, stronger, and does not injure the rope fibers. The figure 8 knot is useful for preventing the end of a rope from slipping through a block or an eye. 2 half hitches are reliable and can be put to almost any general use. And they can be tied quickly. This is a round turn, and 2 half hitches, which can be quickly tied, is reliable and can be put to almost any general use. The pipe hitch is used for hoisting tubular objects, such as pipes. This is another knot that is called the pipe hitch. Here the bight of the rope is used. The bowline is a universal knot. If it is properly tied, it never jams or slips. Single bowlines can be used for hoisting or hitching. 2 interlocking bowlines can be used to join 2 ropes together. The running bowline is mainly used for hanging objects with ropes of different diameters. The weight of the object determines the tension necessary for the knot to grip. The bowline on the bight is a bowline tied in the middle of a line. It can be used to make a set of double leg spreaders for lifting pipe. Crane hand signals are a standardized set of hand and arm positions and movements understood by the crane operator and the spotter. They allow the spotter to efficiently communicate with the crane operator over significant distances. If the operator can see the spotter and the spotter can see potential hazards, loads can be moved safely even though the operator doesn't have a direct line of sight. Learn and practice the signal for emergency stop. Some heavy lift cranes have a main hoist and a whip line. Learn and practice the signal for use the main hoist. Learn and practice the signal for use the whip line. Learn and practice the signal for hoist the wire slowly. Learn and practice the signal for hoist the wire. Learn and practice the signal for lower the wire. Learn and practice the signal for lower the wire slowly. Learn and practice the signal for retract or shorten the boom. Learn and practice the signal for extend or lengthen the boom. Learn and practice the signal for raise the boom. Learn and practice the signal for lower the boom. Learn and practice the signal for raise the boom and lower the wire. Learn and practice the signal for lower the boom and hoist the wire. Learn and practice the signal for move the load in this direction.